In this video, I'm going to talk about linear equations in one variable and proportions. It's quite possible that most of this will be a review for you all, but I'm going to go ahead and go into detail and hope that I can answer any questions that you might have. Alright, so definition of a linear equation. A linear equation in one variable x is an equation that can be written in the form ax plus b. ax plus b equals to 0, where a and b are real numbers, meaning they could be positive, they could be negative, they could be fractions, they could be decimals, and a is not equal to 0. So the reason we have to include that is because if a was 0, then it would no longer have this variable term, and it would just be a constant equals to 0, which would not be a true statement. When we're solving an equation in x, what we're doing is determining all values of x that result in a statement when substituted into the equation. And these values are called solutions. So if we just look at a basic linear equation, if I had x plus 3 equals to 5, what you're doing is you're actually trying to find the value of x that works in this problem. Well, that's pretty straightforward. We know x would have to be 2. And we know that because 2 is the number that would make this a true statement. So 2 is called our solution. And so that's what we're going to be doing in this section, is we're going to be actually solving equations. And I'm going to go over the different steps you need to take to solve these equations, and I recommend that you use these. Even though this was very straightforward and you could figure out what x was, I highly recommend that you use these steps each time. Alright, so the first thing we need to know are the addition and multiplication properties of equality. And the addition property of equality says that the same real number or algebraic expression may be added to both sides of an equation without changing the equation's solution set. So they show you here that we have a equals to b, and if we add c to this side, we must add c to this side to keep our equation balanced, for lack of a better word. So it's saying these are two of the same equations. You guys have done this before when you were solving equations. You add the same thing to both sides, but this is based on the proper addition property of equality. And the same thing works for subtraction, because technically subtracting is adding a negative or adding the opposite sign value. So therefore, the subtraction falls under the addition property of equality as well. You can subtract c from both sides, and your value still stays, your equation stays the same. Same thing for the multiplication property. If I have a equals to b, if I multiply a times c, I have to multiply b times c as well to keep my equation balanced, or to have equivalent equations, as long as c is not equal to 0. And the reason is because if you think about division, which is simply multiplying by the reciprocal, so if I divide this side by and divide this side by c, we cannot divide by 0. That is undefined. So again, the multiplication property of equality also holds true for what we call division, because division is simply multiplying by the reciprocal. Okay, and all these properties really say is that if you perform an operation to one side of an equation, you have to perform it to the other side of the equation in order for the equation to stay true. When we solve a linear equation, there's 4 steps we're going to take. The first step we're going to do is to simplify the algebraic expression on each side by removing grouping symbols and combining like terms. And this is what we did in the previous section. We combined like terms, we used the distributive property, we simplified as best as we could. Then you're going to collect all variable terms on one side and all the constants or numerical terms on the other side. Isolate the variable and solve. And then the last thing is to check the solution in the original equation, because you can always tell whether or not you got the right answer, because if you substitute your value back into the equation, it should always give you a true statement. So let's look at a couple of examples. Alright, so my first one here is 8x equals to negative 24. And hopefully you guys are looking at these and think, okay, that's pretty straightforward. I'm going to do several examples and then let you guys work on some between now and Tuesday, and then if you have questions, we can talk about them in class. Okay, so the way I always say to look at this is to go straight to your variable and ask yourself what's happening. So if we go to our variable is x. We're multiplying it times the 8. So our goal is to get by x by itself, so we have to, in a sense, undo our operations. So the opposite of multiplying by 8 is to divide by 8, or multiply by 1 over 8. And as the multiplication property of equality says, if you perform an operation to the left-hand side, you must also do it to the right-hand side. 8 divided by 8 is 1, which was our goal, because our goal is just to find 1x, and a negative 24 divided by 8 is a negative 3. You can check your work by simply substituting it in. 8 times negative 3, and the question is, does this equal to negative 24? And 8 times negative 3 is indeed negative 24. Pretty straightforward. Hopefully this is a review, but if you're struggling with it at all, feel free to send me an email, ask questions. Okay, so number 2, 3x plus 8 equals to 50. And so for this problem, we have a couple of things going on here. Our variable is x. We're multiplying it times 3 and then adding 8. So as the instructions said, you want to get your constant terms on one side and your variable terms on the other. I typically leave my variable terms on the left-hand side and my constant terms on the right-hand side, but it's really what works for you. So here, 3x plus 8, just like the order of operations tell you to multiply and divide before you add and subtract, it's the opposite when we're solving. We want to undo any addition and subtraction before we undo multiplication or division. So we want to perform I use the term undo, and that's not necessarily a mathematical term, but we want to perform the opposite operations, starting with removing everything from your variable term. So this is a positive 8, so I need to subtract an 8 from both sides. And when I do that, I'm going to end up with 3x plus 0, giving me just 3x, is equal to 42. Now we just left with a variable term on our left-hand side and a constant term on our right-hand side. Our variable is x. We want to get x by itself, so to isolate that variable, we divide by 3. Whatever you do on the left-hand side, we must do on the right-hand side, and we end up with 1x equals to 14. Alright, so let's check that. And when we do that, we get 3 times 14 plus 8, and the question is, does that equal to 50? 3 times 14 is 42. 42 plus 8 is indeed 50. Alright, let's check out problem number 3 here. A few more steps. So the first thing we have to do, as is said, noted on the previous example, or excuse me, steps, simplify the algebraic expression on each side by removing grouping symbols and combining like terms. So we have a grouping symbol here, but we cannot combine these terms, so therefore we want to distribute. This is going to give me 30x plus 20 equals to 70. Then I want to get my variable terms on the left-hand side and my constant terms on the right-hand side. Or just on one side, I tend to move my constant terms to the right-hand side. My variable is x, so the first thing we want to do is to remove everything from this term. So I'm going to move my constant, so I'm going to subtract 20 from both sides. And when I do that, I'm going to end up with 30x plus 0 equals to 50. And then I can divide both sides by 30 because I want to get here I have my variable term by itself and my constant term by itself, and then I want to get my variable by itself. Isolate the variable, and when I do that, x is equal to 5 over 3. So let's check ourselves here. And so if I substitute into the original equation, 3 times 5 over 3 plus 2 equals 70. This is going to be 10, and our order of operations tell us to simplify what's inside the parentheses first. These 3's divide out and give us 1, and I end up with 5 plus 2. And the question is, does this give me 70? And this is going to be 10 times 7. I would not distribute here. You can distribute, but there's no reason to because these are like terms. We can combine them. And 10 times 7 is indeed 70. And so we know our answer is correct. And remember, these are our answers. These are not our answers. Alright, so I'm going to erase this so I have room to do that last problem. You can obviously go back in the video if you have any questions and want to see those. Let's take a look at this last problem here. This last problem is number 4. 2x minus 7 equals to 6 plus x. So the first thing we want to do is simplify both sides. On the left-hand side, these are unlike terms, so I can't do anything with those. On the right-hand side, those are unlike terms as well. There's no grouping symbol, so nothing to be done. So now I want to move my variable terms to one side and my constant terms to the other. I like to move my variable terms to the left-hand side. So I have a plus x here, so to remove it from this side, I want to perform the opposite operation. So I'm going to subtract an x there and subtract an x there. And typically I have students that often like to say 2x minus x just leaves you with a 2, but really what you're saying is if you have 2 x's and you subtract 1 x, you're just left with an x. So the x's don't disappear. Minus 7 equals to 6 plus 0. I have a variable term and a constant term here, so I'm going to perform the opposite operation here. I'm going to add 7 to both sides. Whatever you do to one side, you have to do to the other. And be left with x plus 0 equals to 13. So let's check that. Going back up to the original problem, I can substitute this in. Notice I'm substituting that, excuse me, this is a 13, not a 7. Notice I'm substituting the 13 in for every x, and when I do this, 2 times 13 is 26. 6 plus 13 is going to give me 19. So the question is, are these equal? 26 minus 7 is indeed 19. So you can see that 13 is indeed the solution, and that's the answer to our problem. Whoop. Okay, so hopefully, like I said, this is just review. I'm going to do some more. Then you guys can get started on your homework. I also want to talk about proportions as well. Alright, so number 5 here, I have 13x plus 14. Actually, just to save us a little time, that problem is very similar to the previous problem. So I'm going to move forward and look at this one. So I have 8y minus 3 equals to 11y plus 9. These are all very similar. This one turns out just a little bit different, so I want to make sure that I want to do this one for you. Okay, so in this problem, on the left-hand side, this cannot be simplified any further. On the right-hand side, this cannot be simplified any further. So I want to move my variable terms to one side and my constant terms to the other. Again, consistently, I always move my variable terms to the left-hand side and my constant terms to the right-hand side. Some of you may choose to move your constant terms to the right-hand side in this case to have positive coefficients, but it's up to you. I want to remove this 11y, so I'm going to subtract 11y from both sides, performing the opposite operation. And when I do that, a positive 8y minus 11y gives me a negative 3y. Minus 3 is a positive 9. This sign always comes down, so notice how I brought this down as well. So that's a positive 9 plus 9, so that's a positive 9. Here I have a variable term and a constant term. I want to remove this constant term, so I'm going to add 3 to both sides. And when I do that, I'm going to get negative 3y equals to 12. Divide both sides by negative 3. Because this is negative 3 times y, I want to divide by negative 3 because my goal is for this to be a positive 1, and negative 3 divided by negative 3 is a positive 1. The temptation often is when this is a negative 3 to divide by a positive 3, but you always want to divide by the same value so that you get a positive 1, and that's going to give me a negative 4. Okay, let's check this. And that's going to be 8 times negative 4 minus 3. And the question is, does this equal to 11 times negative 4 plus 9? So let's check and see. This is 8 times negative 4 is going to give me a negative 32 minus 3. 11 times negative 4 is going to be a negative 44 plus 9. And a negative 32 minus 3 is going to give me a negative 35. And negative 44 plus 9 is indeed a negative 35. So our answer is correct. All right, 2 more problems here. For problem number 7, we have to clean up both sides, simplify both sides. We cannot combine like terms, cannot perform the operations inside the parentheses, so here we need to distribute. So when I distribute, this is going to be 8y plus 16 equals 6y plus 8. I want to move my constant terms to one side, my variable terms to one side, my constant terms to the other. So I want to remove this 6y, so I'm going to subtract 6y, perform the opposite operation. That's going to give me a 2y plus 16 equals to 8. I want to remove this constant term so I can subtract 16. And so 2y, and then it's going to be plus 0, so it's going to be 2y is negative 8. Divide both sides by 2. 2 divided by 2 does indeed give me 1. Y equals negative 4. I'm going to check my work real quick. This is 8. It's negative 4 plus 2 equals to 2 times 3 times negative 4 plus 4. Let me see, did I do that correctly? So negative 4 plus 2. 2 times 3 times negative 4 plus 4. Okay, so this is going to give me 8 times a negative 4 plus 2 is a negative 2. 2, and then this is going to give me a negative 12 plus 4. 8 times negative 2. This is 2. This ends up being a negative 8, so we're on the right track. So this is a negative 16, does indeed equal to a negative 16. So our answer is indeed negative 4. All right, let's take a look at one last problem on this page. Number 8. 5x minus 4 times x plus 9 equals 2x minus 3. And let's see. So again, the first thing we want to do is simplify both sides. So I cannot combine like terms here. I can't simplify anything in the parentheses, so I need to start by distributing. So this is going to give me a 5y. This is a negative 4, which is plus, or excuse me, a minus 4, which is plus a negative 4, so that's going to become a minus 4x. And this is going to become a minus 36. That subtraction out here changes the sign of each term inside that parentheses, equals 2x minus 3. I have like terms here. 5x minus 4x is x minus 36. Now, I've simplified both sides. Now I need to move my variable terms to one side, my constant terms to the other. I'm going to move 2x, remove 2x from this side by performing its opposite or its inverse operation. And do the same thing over here. X minus 2x, remember this is as if it's an understood 1 there because there's only one x. If I have a 1x and I subtract 2x, 1 minus 2 gives me a negative 1. So this can become a negative x. Remember to bring this down, minus 36, and again bring this down. 2x minus 2x is 0, but this is going to need to be a negative 3. I need to move my constant terms to the right-hand side, so this is in minus 36, so I'm going to perform the opposite or the inverse operation, add 36 to both sides. Bringing down my negative x plus 0 equals to a 33. Now we're not finished because when we solve, we're actually finding the value of x, and this is a negative x, so we can again think of this as a negative 1, divide both sides by a negative 1, and x equals to a negative 33. All right, let's check this one, and let's see how we did. So I'm going to check it over here. So I'm going to say 5 times negative 33 minus 4 times negative 33 plus 9. The question is, does this equal to 2 times negative 33 minus 3? And so, let's see, 5 times 33. It's going to be a negative 165 minus 4 times negative, what's that going to be, negative 24? And this is going to give me negative 66 minus 3. Let's see, 4 times 24. So this is going to be negative 165 plus 96. And the question is, does this give us a negative 69? And negative 165 plus 96. Oh, I typed it in wrong. 165 plus 96 does indeed give us a negative 69. And so we know our answer is correct. Okay, so I'm going to stop there, and then my last video will cover proportions, and hopefully this will give you some good problems to look at when you're doing your homework. And like I said, please send me an email if you have any questions.